Good morning, class. We are looking at Calculus 1, final exam review, covering from section 2.1 to 6.1. Here's the second part. Covering chapters 3, 4, 5. Chapter 3, differentiation rules. Chapter 4, application of differentiation. And chapter 5, integrals. Here's the pledge. When we take the exam, we take the exam on our own. Simply put, I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. All right. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age in days, and the function is W equals 3 plus 0.21 T. How long is the tiger when it's 100 days old? So just plug in T. You have two choices. You can find L as a function of T, or just plug in T here, equals 100. This is 21 plus 3 becomes 24 kilograms. Replace the weight with 24 kilograms in this equation, and you come up with 969.369 millimeters, almost 1 meter. At what rate is the length increasing when it's 100 days old? dy dt is dy du, du dt. We are interested in dl dt, and the intermediate variable from L to T is W, so dl dw, dw dt. And taking the derivative with respect to W, 0.25 times 2.6, W to the power of 1.6. This is 2.6 minus 1. And then dw dt is just 0.21. The product of these three numbers we put first. And we have two choices. We can replace the W with the function 3 plus 0.21t, or because we are interested in the rate when it's 100 days old and the weight is 24 kilograms, replace the W with 24, and you come up with the answer 22.0532 millimeters per day, dl dt, units of length over units of time. The second method is to find the composite function, because the composite function is not too difficult to find. L of t, replace the W, and you get L of t equals 0.25. W is replaced with 3 plus 0.21t to the power of 2.6. And for part A, we're going to put 100 for t, and we end up with the same answer as we had here. Differentiation. dl dt, or L prime of t, if you want to differentiate this, is 0.25 times 2.6. This went to the power of 1.6, and the derivative of the inside is 0.21. This is using the extended power rule. Multiplication of these three numbers gives us this, and compared to what we had here, as you can see, the two are identical. And now if you replace the t, you come up with the answer, and we are done. Find an equation of a tangent line, and obviously we are going to use the implicit differentiation. Notice this is x times e to the power of y. This is y times e to the power of x, and so we're going to use the product rule first and foremost to come up with the derivative, and then the slope by plugging in. So f prime g plus g prime f x gives you 1 times e to the power of y, and e to the power of y gives itself, times y prime, because y acts like g of x. Remember, the derivative of e to the power of g of x is e to the power of g of x times g prime. So times y prime, and then times x. So f prime g plus g prime f. And now this part. Y, the derivative is y prime times e to the power of x, which is g, and g is e to the power of x itself, times y, which becomes is equal to 0, because the right side is the number. Now, we keep these two because they involve y prime, and we take this one and this one to the other side, and we make both of them negative. These two, we take out the y prime, and when we take out the y prime, it becomes e to the power of y times x. This is e to the power of x. This one and this one, both of them go to the other side. We put a negative sign in front. We divide by this parentheses, and there you have it. So that's y prime. What is the slope? Plug in. So we're going to write slope is y prime such that we use the pair 0, comma 1. Let's plug in as we do. Obviously, this is 0, this is 1, this is 1, and we get minus e plus 1 over 1, and we change the sign for the numerator, we get minus e minus 1. And because this is the y-intercept, we're going to use y equals mx plus b. M is minus e minus 1, and b is simply 1. And that's the final answer, everybody. We're going to differentiate, and we notice it's the product of e to the power of 2x times ln x, therefore f times g, therefore we are going to use the product rule, everybody. F prime e to the power of 2x is itself times 2 because it's not just x, the function of it. Okay. And times ln x plus ln x is 1 over x times e to the power of 2x. And as you can see, you just simply take out the common factor of e to the power of 2x, and it becomes e to the power of 2x times 2 ln x plus 1 over x. Log, the first thing we do is to simplify and decompose a log if we can do that. As you can see, there's nothing we can do to simplify it further as we look at various properties. So you take the derivative by simply flipping this over. The derivative of log is 1 over f of x, 1 over x squared plus. Then f prime of x. By the chain rule, I need its derivative, which is 2x. And then I look at the base. If the base is I'm done, it's not 1 over ln b, therefore I need 1 over ln 5. Now, the final answer, when we put them together, it's in such a manner that the denominator is the product of these two, and the numerator is just 2x because times 1 times. In this case, we're going to decompose it first using number 6, the quotient rule, ln of top minus ln of the bottom, ln of 2x minus ln of 2x plus 1. And ln of 2x, we use 5. So maybe I quickly write that first. So ln of 2x minus ln of 2x plus 1. And ln of 2x is ln 2 plus ln x by number 5, the product rule. And I'm going to erase my board so I can continue. Obviously, ln 2 is a number, therefore the answer is 0, and ln x is 1 over x. So what do we do? This one minus, flip this over, 1 over 2x plus 1, and by the chain rule times its derivative, which is 2. The LCD is x times 2x plus 1, so this becomes 1 times 2x plus 1 minus 2 times x. 1 doesn't do much, so this one and this one cancel each other. The numerator is simply 1, and the final answer is f prime of x equals 1 over x times 2x plus 1. Logarithmic differentiation, y equals x to the power of sine x. Generally speaking, when the base and the exponent, both of them are functions, one methodology is logarithmic differentiation. So what is logarithmic differentiation? Take natural log of both sides first. When we do that, the right side, we can put the sine x in front because we're going to use number 7, the power rule. Now we're going to differentiate implicitly with respect to x. So when you differentiate, this one is 1 over y times y prime. The right side we use the product rule, f prime g plus g prime f. So sine gives you cosine times ln x. Ln x gives you 1 over x times sine x. So we're going to put this over there. That means we're going to multiply both sides by y. That means we are going to solve for dy dx for y prime. So put y to the other side. And finally, replace the y with x to the power of sine x, cosine x ln x plus 1 over x sine x, and you're done. The second method is to remind everybody that e to the power of ln x is equal to x. Therefore, we can replace the x with e to the power of ln x. If I do so, x to the power of sine x becomes e to the power of ln x sine x. That means e to the power of ln x times sine x. And this one we know how to differentiate when it comes to exponentials. And you can finish it that way. And it must give you the same answer we received here. And it will. We're going to differentiate this, and we notice it's the product of x and sine inverse. We put a raised out in between, and we call it f times g, which is f prime g plus g prime f. And so f prime is simply 1 times g, which is sine inverse of 3x. Plus, now g prime, the sine inverse, the derivative of sine inverse is 1 over square root of 1 minus x squared. If it happened to be u, we say du dx over square root of 1 minus u squared. Or if you call it g of x, is 1 over the square root of 1 minus g of x quantity squared times g prime. So we are going to put it in this format. In other words, what goes in here, what goes in here? If you follow that, this is g of x, and our g of x is this one, everybody. So we're going to put it here. And at top, the u dx, or at top g prime of x goes here. So 3 goes here. So 3, because it's the derivative of the argument of sine inverse, and 3x because it is the argument of sine inverse. And of course, times f x. And we just rewrite it. Notice this is simply sine inverse. This is 3x in the numerator, and this is 9x squared, so 1 minus that. So sine inverse of 3x plus 3x over square root of 1 minus 9x squared. That's how we write it. We do the same thing. First and foremost is the product of x and cosine inverse. We are going to write it as f times g, and to handle this, we're going to write it as 1 minus x squared to the power of 1/2, just to make sure we are able to handle it in this manner. So first of all, f prime is 1, so times cosine inverse. G prime, cosine inverse. The derivative is just like sine inverse, but negative. So 1 over square root of 1 minus x squared becomes just negative. So minus, so we're going to write plus negative 1 over square root of 1 minus x squared times f, which is x. So we're done with this piece. Now we move on to this one. This is 1/2 times 1 minus x squared to the power of 1/2 minus 1, which is negative 1/2, and times the derivative of the inside, which is negative 2x. And this is using the extended power rule, everybody. So first, let's look at this one. This goes down and takes a positive exponent. And this is at top. So let's just look at this one. Now, this one cancels out this one. You get minus x. Negative outside makes it positive. So we have cosine inverse minus x over square root of 1 minus x squared plus x over the same thing. This one is the same as this one, everybody. And These two cancel each other, and the final answer is simply cosine inverse. So that's pretty straightforward. I hope everybody's okay with that. So the y dx is simply cosine inverse of x. All right. The distance in meters of an object from a starting point is given, where t is time in seconds. What is the velocity from 2 to 4? This is an average velocity. S of t sub 2, that means S of 4 minus S of t sub 1, that means S of 2 over t sub 2 minus t sub. So we have 4 minus 2 in the denominator. We're going to put 4. 2 times 4 squared minus 5 times 4 plus 40. And then we plug in 2. 2 times 2 squared minus 5 times 2 plus 40. That would be the numerator. This simplifies to 52 and this one to 38. So 52 minus 38. And it becomes 7 meters per second, units of the numerator over the units of the denominator. The next part is asking for the instantaneous velocity. So what is the instantaneous velocity and acceleration of the object? What is the velocity of it and acceleration of the object after 6 seconds? You simply go back to the same function, the distance function, and you take the derivative. For t minus 5, you want it after 6 seconds. You plug in 4 times 6 minus 5 is 19 meters per second. Acceleration is defined as the second derivative of the position function. Therefore, a is v prime is s double prime. The derivative is 4, and it happened to be independent of time. Therefore, whether it's after 6 seconds, 5 seconds, or any time, it's still 4. The units are meters per square second because this is dv dt. And so meters per square second. When does the object reach the velocity of 31? So set this equal to 31. Move this, you get 36 divided by 4 is 9 seconds. A 180-degree turkey is removed from the oven and placed in a 74-degree Fahrenheit room. After 15 minutes, it has cooled down to 136 degrees Fahrenheit. Find the general solution for it. This is the Newton's law of cooling, and we are going to write the information as follows. This is the initial value, T sub 0. Capital T sub 0 represents the temperature is 180 degrees. The room temperature is the surrounding temperature T sub s. And then after 15 minutes, capital T of 15, lowercase t is 15. We have 136 degrees Fahrenheit. So this is the given information. And according to this formula, and we have proved that that formula works, that y sub 0 is T sub 0 minus T sub s. So the difference between the two is y sub 0. And the difference is 106 degrees. So we are going to go with this formula and replace the y sub 0. And now the fact that T of 15 is 136, we're going to use that to find the missing k. Now, first thing first, we subtract 74. We subtract 74 from 136. . . we get 62. Then we divide by 106. Now, I'm not going to even simplify it, although you can, and it becomes 31 over 53, but keep it. Let's take a natural log of both sides. So the left side simply becomes the exponent 15k. And if you divide the right side by 15, that's the value of k. Put it into a calculator with a bunch of decimals, and you get the general solution for capital T of t. There's a second method, and that is starting from here. We simplify to 31 over 53, and we are going to find e to the power of k. To find e to the power of k, you have to raise this to the power of 1 over 15. And you do it to both sides. And now, if this is the one, we want e to the power of kt. So we're going to raise this to the power of t, and we're going to raise this to the power of t. And now we can replace e to the power of kt with this expression. And the point being, this one uses e, this one uses 31 over 53 as the base, and they both work fine. So when we go to the next page, we're going to write capital T of t is both of them. So for part B, when they're asking what is the Turkish temperature after 60 minutes, because 60 is divisible by 15, it's easier to use this one. Because 60 divided by 15, as you know, it's 4, everybody. So you raise this number to the power of 4 multiplied by 106 and add 74, and you get 86.4065 degrees, again with a bunch of decimals, and you can always round it just the way they ask you. How long does it take to cool down to 110 degrees? You use one of them and you set equal to 100. So first, we're going to move the 74 and subtract it, and we get 36. And then we're going to divide by 106. Then we're going to take the natural log of both sides. Again, I'm not going to simplify this. And if you have the natural log of e, then they undo each other and we get just the exponent. If you divide by this coefficient, it becomes the t. Put it into a calculator, maybe with one decimal or so, 30.2 or about 30 minutes. And again, as far as the number of decimals, you always follow what they ask you. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area is changing when the radius is 4 feet. So you're looking at the circular shape. You should know, here's the radius, is the diameter, d equals to r, circumference is 2 pi r, a is equal to pi r squared. And what is given is this, which is dr dt is 3/2 feet per second. And we want the ADT when r is 4 feet. So draw the setting and define your variables and write this symbolically. A is pi r squared, and you want the ADT. The ADT, you start with pi and you say it's a coefficient, it's not going to do anything. R squared is 2r dr dt. So you have 2 pi r dr dt. Replace the r with 4 and dr dt with 3/2, and it becomes 12 pi square feet per second, units of area over units of time, and it's an approximation. Always write the exact answer, and then if need be, the approximation. We want to find dy dt for this equation, and the moment you see dy dt, it indicates that the independent variable must be t. So we're going to use the extended power rule, 4 times the same thing cubed times the derivative of inside, and because t is independent variable, 5x gives you 5 dx dt, y gives you dy. Minus x gives you minus dx dt, and any number results in 0. I can solve for dy dt or simply just plug in. When you plug in, 5 times 2 is 10 minus 9, 1 cubed is 1, so this is 4 times 1, and this is 15. Distribute, you get 60. And for dy dt, 60 and minus 3, they end up being 57. Move it to the other side, becomes negative 57. Divide by 4. And the final answer, dy dt is negative 57 over 4. A 20-foot ladder leans against the building. The base slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. We have to do the drawing. The drawing explains everything that was just discussed. So we have this situation. We have to define our variables. The base is x, the height is y, and at the moment that is 12 feet, we want to see what's happening. As it moves this way, it creates a speed dx dt is 2 feet per minute. As it moves this way, this moves down, and it creates a speed dy dt that we don't have. And we have to figure out, everybody. So you are going to write this. And the ladder is fixed, it's 20 feet. So we are going to write dx dt is 2 feet per minute, dy dt is missing, x is 12 feet, we want to find dy dt at that point. So clearly, this is a 90-degree angle, follows the Pythagorean theorem, a squared plus b squared is c squared, that means x squared plus y squared is 20 squared. You differentiate 2x dx dt plus 2y dy dt, and it's 0 because 20 squared is 400, and it's a number, and the derivative is 0. Now we can plug in and find the missing dy dt. We notice everything is there except y. So when x is 12, we put it into this one. X squared is 12 squared plus y squared equals 20 squared. 12 squared is 144. This is 400. We are going to subtract 144 from both sides. Get 256, and y is plus minus 16, and you keep the positive only. And now you have everything except dy dt. 2 times 12 times 2 is 48. 2 times 16 is 32. We're going to move the 48 and make it negative. Divide by 32, and we get negative 3 halves. Units, feet per second. The units of y over the units of t. Okay, the height over the time. And of course, x is increasing, dx dt must be positive, y is decreasing, and must be negative, and it indicates it right here. Falling sand is forming a cone-shaped pile. The volume is increasing at this rate. The height of the cone is twice the radius. Find the rate at which the radius changes when the radius is 6 inches. First and foremost, here's the shape. And the volume is 1/3 power squared h. That's a piece of information we should have. Now we go back and we reread the question, and we notice this is dv dt. H is 2r. And we want dr dt when r is 6. In other words, this is the same question put symbolically. And of course, this one, a piece of information from algebra / geometry. This is a function of two variables, r and h. And because we want dr dt, we make it a function of r by replacing the h with 2r. And this obviously is 2/3 pi r cubed. And now the volume is a function of one variable r. We are going to go with dv dt, and 2/3 pi is just a number and a coefficient and remains. So you deal with r cubed, which is 3r squared dr dt. Or 2 pi r squared dr dt. We replace dv dt with 54 pi and r with number 6. This is 36 times 2 pi is 72 pi dr dt, and dr dt is the left side 54 pi divided by 72 pi. and these two cancel each other. The pi cancels out, and the two numbers have a common factor of 18. They get 3/4 of an inch per minute. Use differentials to approximate the square root of 27. And I'm going to just reminding you that f of x plus delta x can be approximated by f of x plus dy. That's the meaning of differential. Use this one. Delta y is a rise along the curve as we go from one point to the next. Delta x is identical to dx, but dy is the rise along the tangent line, and dy can approximate delta. So first and foremost, you need a function. And how do you find the function? Just read this square root of 27. The action, the operation, that means square root of x. Number two, you have to find a number that is close to 27, and we know the root of, obviously, the closest number is 25 because its square root is 5. And now it gives rise to delta x. So as we move from the known 5 to, or known square root of 25 to unknown square root of 27, delta x or dx becomes positive 2 because it's 27 minus 25. Again, just to emphasize how we came up with that, if for the sake of argument, we wanted square root of 24, then dx would be negative 1, okay? Because that would be 24 minus 25 in any event. And obviously positive means this is larger than 5, negative would be less than 5. So we have f of x plus delta x is f of x plus dy. We have f of x and dy is missing, so we are going to differentiate this by rewriting it as x to the power of 1/2. You've seen the answer becomes 1/2 square root of x, or just quickly f prime is 1/2 x to the power of 1/2 minus 1, which is negative 1/2, so 1/2 square root of x, and dy is the same thing times dx. And so you have everything. You want square root of 27. That means you want f of 27, f of 25 plus 2, and that means x is 25. And dx or delta x is 2. Plug in. This is obviously 5. These two cancel each other. 5 and 1/5, or 5.2. Just for reference, we put that into a calculator. As you can see, with one decimal becomes 5.2, with two decimals becomes 5.20, and that's pretty close. We also can use linearization. Linearization refers to finding the tangent line, and we don't have to memorize anything. We're going to go with the point slope, which means first we need to know, if you want to find the tangent line, what function, at what point the function is square root of x at x equals 20. So at x equals 25, you plug in, you get 25 comma 5 is the pair, and 25, you put it into f prime, 1/2 square root of x. So again, I want to make sure that everybody understands. If I put this into this, I get the pair 25 comma 5. If I put it into this, I get 1/10. That's how I get my information. Now y minus y1. So we are going to go with the easy way out, y minus y1. So let me. In other words, you don't have to memorize the formula for L of x, just the point slope. So with that being the case, y minus 5 is 1/10 x minus 25. This is 1/10 x minus 25 over 10 plus 5, and it simplifies to 1/10 x plus 5. I'm assuming everybody can do that. Now, square root of 27 is L of 27, and if you go through the process, you get 5.2, which is identical to this. If these two numbers are not identical, because differentials and linearization must give us the same answer, we've made a mistake somewhere, so you want to be careful with that. ddx of sinh x. We want to, as you recall, when we looked at hyperbolic functions, Cauchy x by definition is e to the power of x plus e to the power minus x over 2. sinh x or hyperbolic sign is e to the power of x minus e to the power minus x over 2. And we said the derivative of sinh is cosh, the derivative of sinh u therefore is cosh u du dx, or sinh of g of x would be cosh g of x g prime of x, and the rest of them follow. The derivative of cosh is sinh and so forth. So what is the derivative of sinh? We are saying it's cosh x. And in fact, we want to prove that. So to prove that, we go with the definition and we're going to differentiate this piece. And I hope you see that this 2, it means 1/2 and it's a multiplier, it remains. So what is the derivative of this one itself? What is the derivative of this one itself times -1 with this becomes positive. And of course, this is, when you look at this one, is cosh. So it's a very simple proof, just in case. Now, what about the derivative of sinh of 10x squared? As I did with trigonometric functions, I'm going to just read sinh and stop, and I say the answer is cosh, right? And then I have to have an argument. The argument of a sinh is 10x squared, or sinh or hyperbolic sign. And then by the chain rule, I need the derivative of 10x squared, which is 20x. In other words, I'm going with this route, and I put the 20x in front, and I'm done. All right, so we want the cosh again. The derivative of a cosh is sinh, and then the same argument. And now the derivative of square root of x, we just did that in the previous page, is 1 over 2 square root of x, and it's sinh square root of x over 2 square root of x as the final answer. What about f of x being hyperbolic tangent of 1 plus e to the power of 2x? And again, we start with hyperbolic tangent. And the hyperbolic tangent, its derivative is hyperbolic secant squared. So we write it. And then, of course, you have to use the same argument. And then you take the derivative of the argument by the chain rule, which is e to the power of 2x times 2. And we rewrite it by putting 2 e to the power of 2x in front. The final answer, f prime of x is 2 e to the power of 2x, hyperbolic secant squared of 1 plus e to the power of 2x. Find the absolute maximum and minimum value of the function f of x equals x squared minus 1 to the power of 3 in the closed interval of -2. So what about the extreme value or closed interval theorem? First of all, recall all functions are continuous in their entire domain. Polynomials, more specifically, that are in the form of a sub n x to the power of n all the way to a sub 0, and a sub n can't be 0, n is a whole number, they are continuous from negative to positive infinity. This is a polynomial of degree 2 times 3 or 6. Therefore, a polynomial of degree 6 is continuous on negative to positive infinity, and it makes it continuous in the given interval of -1 to t, -1 to 2. Therefore, we're going to use the closed interval theorem that says if you have a closed interval and a continuous function, then you must have an absolute max and mean, and the process is to find the CP. That means start with f prime of x. So 3 times x squared minus 1 squared times the derivative of inside is 2x, and we put them together in the same format, 6x times x squared minus 1 quantity squared. And you set that equal to 0. And when you do that, either x is 0 or x squared minus 1 is 0. That means either this one is 0 or x squared is 1, and you have 3 answers, plus minus 1 as well as 0. Now, f prime does not exist, doesn't produce any solution, because f prime itself is a polynomial of degree 5. 2 squared, 2 times 2 is 4, and this is 1, so 5. And so all three work out because they are in the interval of -1 to 2. And the reason is because one of them is the endpoint, 0 and +1 are in between. So we're going to evaluate the original function at all those points. The original function x squared minus 1 cubed. If I put -1 here, becomes +1 minus 1, 0, 0 cubed is 0. By the way, 1 works exactly the same way. If I put 0 here, I get -1 cubed, which is -1. And as I said, 1 works just as well as -1. And if you put 2, 2 squared is 4 minus 1, 3 cubed is 27. This is the absolute max. This is the absolute mean. And we write absolute max is 27 at this pair, 2, comma 27. Absolute minimum is the -1 at this pair, 0, comma -1. The mean value theorem, given f of x equals 5 minus 4 over x, find all c in the interval of 1 to 4 such that the slope of the secant line equals the slope of a tangent line. Reminding you, according to the mean value theorem, f is continuous in the closed interval of a to b, is differentiable on the open interval of a to b, then there's a number c such that f prime of c is f of b minus f of a over b minus a, or the cross product gives you that, which means if you connect the endpoints and it gives you a secant line, you can calculate its slope using this formula, obviously, which is this slope formula that is rise over run. There must be a tangent line parallel to that. That's the meaning of that. So what we are dealing with is the following graph. It's a rational function. And as you know, the rational function, the domain is all real numbers except what makes the denominator 0. You can write it in this fashion, or you can write it as 5x minus 4 over x. Either way makes no difference, everybody. The fact of the matter is that the domain is all real numbers except what makes the denominator 0, which is 0. So you write the domain is all real numbers except 0. Now let's look at the graph in the following manner. Just that was too fast. So at 1, we are here. At 4, we are here. We connect them, and there's somewhere in between that we are looking to find, such that the tangent line is parallel to the secant line. The blue line is the secant line. And so f is a rational function. Therefore, f is continuous from -infinity to 0, union 0 to infinity. Now, since we wanted from 1 to 4, and 1 to 4 is in this interval, so therefore it is continuous in the closed interval of 1 to 4 and differentiable in the open interval of 1 to 4. The reason it's differentiable, it's a nice and smooth curve. It's differentiable everywhere except, of course, everywhere in its entire domain. Okay. And so the next part is to calculate f prime of c. That means f of 4 minus f of 1 over 4 minus 1. If I plug in 4 here, everybody, 4 over 4 is 1, 5 minus that. So just for the sake of argument, we quickly plug in 4 here. I hope you see that it's 5 minus 1 is 4. If I plug in 1 here, okay, I get 5 minus 4. Okay, and I get 4 minus 1 in the numerator over 4 minus 1 in the denominator, which is 1. So you can easily evaluate f of 4, which is 4, and f of 1, which is 1. And so that takes care of that. Also, let me erase my word. If I want to differentiate, if you look at this one is minus 4, x to the power of minus 1. And its derivative is, if I want to differentiate that, is minus 4 times -1, x to the power of minus 2. Is minus 1, which makes it minus 2, or f prime is 4 over x squared. So we have to set the f prime equal to 1. X squared becomes 4, x becomes plus minus 2. There are two answers, and there's only one answer. 2 in the interval of 1 to 4, there's only one answer, everybody. So C is 2. Although -2, so this is 1 and 2 to the left. So right here also we have another one, but in the given interval, there's only one. And I'm going to remind you, according to the Rolle's theorem, the last one, we have the first two, and the last one, f of a equals f of b. And in that case, then f prime becomes 0. In other words, Rolle's theorem is a special case of the mean value theorem. All right, we want to find the limit. And as you recall, if you could set it equal to 0 over 0, infinity over infinity, you can use L'Hopital's rule. So if I plug in 1, I get ln 1, which is 0, and this is 1 minus 1, 0. Therefore, I can use L'Hopital's rule. L'Hopital's rule says, if you want to take the limit of f of x over g of x as x approaches a, if you prove it's 0 over 0, infinity over infinity, you can say, I'm going to take the derivative of the top over the derivative of the bottom, and then do the math. So the derivative of the top is 1 over x, and the bottom is 1. And that is simply limit of 1 over x as x approaches 1. And if I now replace it, I get this one. I want to quickly just show you the first one, and then the rest of them we're going to look at. So if I plug in, I get e to the power of 0 minus e to the power of minus 0 is the same as 0 minus 2 times 0 over 0 minus sine 0. I hope you see that these two cancel each other because they're 1, and everything else is 0. 0 over 0 means I can use L'Hopital's rule. So if I'm using L'Hopital's rule, that means limit as x approaches 0. This is e to the power of x. This is minus and minus plus e to the power minus x. This is minus 2. 1 minus sine x becomes 1 minus cosine x. Now, if I plug in 0, again, these two, 1 and 1, 2 minus 2 is 0. Cosine of 0 is 1. 1 minus 1 is 0. Again, 0 over 0. I'm going to use L'Hopital's rule. This one is itself, minus e to the power minus x. This goes away. Minus cosine is sine x. If I plug in 0, I get e to the power of 0 minus e to the power of 0, which is 0, and sine of 0 is 0. And I can use the L'Hopital's rule again. This is itself. This is plus e to the power of x. Sine is cosine. As you know, this is 1. If you plug in 1 plus 1, cosine of 0 is 1, and the answer is 2. So the point of this question is, you may use L'Hopital's rule again and again, and that's fine. What about this one? And the point is, plug in and observe. This is 1 minus sine of pi over 2. If I plug in 1 minus sine of pi over 2, as you know, sine of pi over 2 is 1. The numerator is 0. This is cosecant or 1 over sine of pi over 2, which is 1 over 1, which is 1. 0 over 1 equals 0. There is no need to use L'Hopital's rule, and that's the key. Don't use it if you don't have to. There are other formats that can use L'Hopital's rule if it's infinity minus infinity, but you have to change them so that it becomes one of these. As it's the case here, if you plug in, you get infinity minus infinity. So the methodology is to remember that cosecant is 1 over sine and cotangent is cosine over sine. Therefore, the common denominator of sine x means the numerator is 1 minus cosine x. Now, if I plug in 0, 1 minus cosine 0 over sine 0 is 0 over 0, and therefore I can use L'Hopital's rule. So if I differentiate the top, minus cosine gives me positive sine, sine gives me cosine, and if I plug in, sine of 0 is 0, cosine of 0 is positive 1, 0 over 1 is 0, and I'm done. Over here, if I plug in, and when I plug in 1, this becomes 0 and 0 from the right. The same thing here. As you know, the graph of a natural log tells you this goes to negative infinity, so does this one. And minus infinity minus negative infinity, that means negative infinity plus infinity, which is the same as this one, is indeterminate. And we can use properties of logs. In this case, if you look at a number 6 log of x over y is log x minus log y, and all of them have the same base b. We're going to go from right to left. And we're going to write the limit as x approaches 1 from the right of natural log of x to the power of 7 minus 1 over x to the power of 5 minus 1. Now you can interchange these two, and if I plug in 1, this becomes 0, this becomes 0, and therefore I can use L'Hopital's rule. This one gives you 7x to the power of 6, this one gives you 5x to the power of 4, and if I plug in, I get 7 over 5. Natural log of 7 over 5 is the final answer. use Newton's method for this. And the first thing is, what is f of x? What is f prime of x? So you have to show how you arrive at f of x. So you let that one be x. If I raise this to the power of 8 and this one to the power of 8, I get x to the power of 8 is 500. And if I take it to the other side, x to the power of 8 minus 500 is 0, which call it f of x is x to the power of 8 minus 500. And now if I differentiate, I get f prime of x is 8x to the power of 7. So that's the first thing you must do if your Newton's method is given. Now, if that is the case, now I can write x sub n plus 1 is x sub n minus x sub n to the power of 8 minus 500 over 8 x sub n to the power of 7, 8x to the power of 8 x sub n to the power of 7. And now the question is, what is the first number you're going to use? And as you look at these two, you can use 2 or 3 or any number in between. It is your choice, but you have to make it clear what is your first choice and why. If that's x sub 1, then according to this formula, x sub 2 must be x sub 1 minus x sub 1 to the power of 8 minus 500 over 8 x sub 1 to the power of 7. So we're going to replace it with 2. And when we do the math, we get 261 over 256 exact. And with decimal, and since they want 8, we want to use a lot of decimals. Now, I have shown how I arrived at f of x, f prime of x, x sub 1, and I did show a detailed work all the way to x sub 2. Now, because it's tedious, I'm going to use a graphing calculator just for this and using the program that I told you. So y1 will be f of x, y2 will be f prime of x. You put x sub 1, which happened to be 2, stored in x, and then you write x minus y1 over y2. In other words, this equation into x, and you get this number. If you do it repeatedly, you notice because you want 8 decimals, you have to continue enough until you get to the first 8 to be identical. 1, 2, 3, 4, 5, 6, 7, 8 are identical, you stop. Next to 7 is 6, so it goes up. So the answer will be 2.1745592. 7 changes to 8. This is the final answer. And again, I repeat, I've shown every step necessary, and then I use the calculator. Here's the last question. We want to use the left endpoints, right endpoints, and midpoints rules with n equals 5 to approximate the integral. Remember, the integral of a to b f of x dx can be approximated by summation of f of x by delta x as I goes from 1 to n. And if you take a limit when n goes to infinity, becomes identical to that. It represents the area under the curve if the function is positive, and otherwise it's the difference of areas, could be positive, could be negative, and so on. So having said that, here's the formula for left endpoints, right endpoints, midpoints. And I'm going to write this one, the general form, as it was mentioned here, which means f of x of 1 times delta x all the way to the last one. Now, I can stick with the formula, and it makes it very difficult to handle it, or I'm going to do the following. Okay, first and foremost, what is my function here? 1 over x. What is my a? 1, b, 2, n is given as 5. So I'm going to quickly graph this function. And I'm interested from 1 to 2, 1 to 2, and I'm interested in this area. In other words, this is the region of interest. Okay. And so, first of all, let me just make it huge. So we want this one that goes from 1 to 2. We make it larger so it becomes easier to see what we want. So the very first thing I need to calculate is delta x. Delta x is b minus a, 2 minus 1, which is 1 over 5 or 0.2. So I'm going to, as I mentioned, I'm going to blow this up. I make it huge, and I'm going to go from 1 to 2. And because delta x is 0.2, I'm going to add 0.2. So I'm going to have 1, which is A. I'm going to have 2, which is B. And then I'm going to add 0.2, 1.2, 1.4, 1.6, 1.8. So for the left end points, This is the beginning, this is the end, and I'm going to use all of them for the height except this one. Remember how the height works. So when you draw this, the left endpoint, okay, become that. Okay, so you're using those points. Okay, so you don't use the last one. So it's delta x times f of those points. So L sub 5, YL left endpoints, Y5, N is 5. So delta x times f, okay, of 1 plus f of 1.2, all of them except the last one because you're using the left endpoints. Now, what is f of 1? 1 over 1. What is f of 1.2? 1 over 1.2, and so on. You calculate it, you come up with the answer here, and you're done. For the right endpoints, I don't use this one, okay? So R5, why R5? Because you're using the right endpoints, and there are 5 of them. So it's delta x times, let me erase my work, delta x times f of 1.2, f of 1.4, all of them except f of the first point. And it's important to notice that, anyways, f of 1.2 is 1 over 1.2 and so forth. And notice that these parts are the same. Which means it really helps with the fast calculation. You put it into a calculator, come up with the answer, and you're done. What about the midpoints? So just look at the first midpoint. It's just 1.1, right? Between 1 and 1.2 is 1.1, or just add them up, divide by 2. Then just add this much. Add 0.2. So delta x, so m sub 5 is delta x times f of these points now. F of 1.1, f of 1.3, f of 1.5, f of 1.7, f of 1.9, add them up. And of course, 1.1, f of 1.1 means 1 over x, 1 over 1.1, 1 over 1.3, and the rest of it. You put it into a calculator. This is the final answer. And this is a better approximation than the other two. Normally, the midpoints do a better job than the right endpoints or the left endpoints.